sitting on a tractor. Sun's hotter than a nuclear reactor. Through the dust I can smell the rain moving in. Another row, I'll be done for the day. Gonna put this John Deere away. Sometimes I think I'm gonna work myself to the bone. Lord knows I ain't complaining about the job I gotta do. I just keep on track, I don't look back until the job is through. 'Cause I'm a working man, living off the land.
Alright, me and Trent decided to do our fluids project on Pascal's principle. And basically what Pascal says is that if you apply a force, incompressible liquid, then that force is evenly distributed throughout the system. And we can represent that idea by this equation right here, which is force of this piston cylinder over area equal to the force over area of this piston cylinder. So one way that we can do this is by getting some syringes and just applying a load and watching the other piston lift the other load, but that's not very fun. So I think we're going to build a crane and see if that works. So first thing we got to do though is we got to find the force that's going to be acting at this point. So next we're going to run through our calculations to calculate that force right there. All right, so as we said earlier, we're going to build a crane. So this is kind of a little sketch up of what we plan on doing. So we've got our two pistons situated like this, and next thing we need to do is to calculate this force like we said earlier. And to do that, we're going to have to draw a free body diagram of this board and find a moment about that board to get our force. So here's our free body diagram. We've got the weight of our board acting at this point, which is the distance between the pin and the end of the board. And we've got this force here, which is acting at the center between the end of the board and this point here. So we've got both of those forces. We have to find exactly how much those forces are, which is the weight. And our weight of our board is 3 pounds. So doing a little bit of math, we get the weight at this point to be 0.5625 pounds. And the weight at this point is 2.4375 pounds. So now we can go find our moment and calculate the actual force at that point. So come over here, plug in our numbers to our moment equation, and we get a force of 15.452 pound force. And next we're going to use Pascal's principle to solve to see what kind of force we're going to need to lift that weight off the ground. So we have this equation here. We're going to plug in our numbers, which is that force over the area of that piston, which was 2 inches in diameter, times the area of our other piston, which we'll be applying the force to, which has a 1 inch diameter. And we get a force of 3.86 pound force. So what that basically says is, using Pascal's principle, our force should be able to lift. We should be able to apply a force at a fourth of what it can lift, what it would be able to lift. So, which proves to be true because if you multiply this by 4, you'll get this force right here. So if you increase it, if you double the diameter, you can lift 4 times the weight. So let's see if it works. All right, so we're going to see what kind of force we need to apply to lift this 3 pound load. I'm going to apply a force here, and based off of our pipes and our dimensions, we're going to calculate the force that's needed to lift that load.
They say an elderly man confronted his wife and her alleged lover Friday morning when they were apparently on their way to a weekend getaway at a Louisiana casino. The